question 1, part 2c is asking us to find the optimal action value function. Now this is very similar to the previous thing we just did, the optimal state value function. The only difference is we're going to be forcing the agent to take a specific action, and then afterwards they're allowed to follow the optimal policy. So when we're thinking about the action value function, we're going to set up 4 expressions. This is in contrast to when we were doing the state value function. We only had 2 expressions, 1 expression for each state. But for the action value function, we need to think about a state and a given action. So I'll set up the 4 expressions now. So for our Q function, we need expressions for each one of these. Now, if you think about it, 2 of these Q functions, we've basically already finished the work for those. If we scroll back up a bit and think about when we were calculating the value functions, let's take a look at how we did that. When we were doing the optimal value for state 1, we were forcing we didn't force the agent. The agent's policy was to take action A2, which got the penalty of -1. But then after that first step, the agent simply followed the optimal policy from state 2. This is exactly the same as QS1A2, this second equation here. So we can literally just read off the result from the previous example that we were doing for state 1. 18.42. And it's a similar case for the Q function down here with state 2 and A2. We already worked that one out to be 21.58. So all that's left to work out for the action value function are the values that the agent can get if it's in state 1, but we force it to take action 1 as the first step. And also if the agent is in S2 and we force the agent to again take A1 as the first step. After those first steps, which we force them to do, they're allowed to follow the optimal policy, just as we did with the state value function. So if you think about it, for the state 1 action 1 value, we're going to start off the expression by giving the agent a reward of 0. Now, if you don't recall the picture of our world, here it is again. I put 0 down here because the agent is currently in S1. We're forcing it to take A1 as the first move, which is this self loop, and we can see that there's a reward of 0 for it. After this first step, I'm going to allow the agent to follow the optimal policy of S1. This is basically what the difference between the Q function and the value function. The value function will simply take the optimal move from state 1. This is how we got to the 18.42 value. We did not force them to take the suboptimal A1 action as the first step. With the Q function, it's different. We're in state 1. We're forcing the agent to take A1, so therefore they get a reward of 0. But then we need to capture the rest of the rewards it can get in the future with another term. And we do that exactly the same way as we did with the value function. So here we get our discount factor and then times it by the optimal value that we can get from state 1. And I'm using the optimal value of state 1 over here simply because if we take action A1, it's the self loop. After we take that action, the agent is back in state 1, and if it starts following the optimal policy at that point, then we get to the value of 18.42. That's how I got this number here. Now I'll just quickly do the calculation for this one. Uh, 0.9 times. So that will be approximately 16.58. And similarly down here for the state 2 action 1 Q value, the agent will get a reward of 1 to start with. If we think back to the diagram, this is the self loop from state 2. He gets a +1 reward for doing that. And then we can use the optimal value from state 2, which we found to be 21.58. So the Q value for this state action pair is approximately 19.42. So you can see here, we've now got all the values for the state action pairs, and basically there's 4 of them instead of 2 like we have for the value function. The extra 2 expressions come from forcing the agent to take the suboptimal move as the first step. Now the way we'd usually report these values is in a state table. So if we go to the questions, part 3 of this question asks us to write the Q values into a table, also known as a Q table. So what that looks like is, just as you would expect, we copy over the table, and then we just read off the values that we calculated. So our Q value for the state 1 action 1 pair, 16.58. The Q value for the state 1 action 2 pair, 18.42. For S1A1 is 19.42. And finally for S2A2 is 21.58. So this little table down here can be used to read off an optimal policy. For example, if an agent is in state 1, it could simply inspect its options. It can either take A1 or A2. Obviously the reward of 18 is greater, so therefore under this policy, the agent would take, in state 1, the agent would do action A2, and in state 2, the agent would take action A2 again, because 21 is bigger than 19. So you can see that that's actually the optimal policy that we worked out in the beginning.